So today we'll look at the fuel cell. So basically, what is fuel? First of all, fuel is basically any burning material. So fuel is any burning material is known as fuel, right? So now let's take an example. For example, we have methane, right? Methane is a fuel. Methane, when combines with oxygen, it is a fuel, right? And it gives us carbon dioxide, water, and heat energy, right? And in the fuel cell, basically we convert this heat energy into electrical energy. Like, this is a basic work of a fuel cell, right? Electrical energy. Basically, this type of reactions are known as oxidation reaction, or most properly they are known as combustion reaction. They are known as combustion reaction, or you can say them oxidation, because oxygen is being combined with them, so that's why they are known as combustion reaction or oxidation reaction, right? So now let's take it as an example in order to elaborate you more. Okay, if we take alcohol like C2H5, which is ethanol, right, with oxygen, it will also give, like, obviously there will be some byproducts, but our main focus is on energy, right? So here heat will be released, and that heat will be converted into electrical energy, and this is a basic principle of a fuel cell. So the cell which we will discuss today is known as hydrogen oxygen fuel cell, right? That is known as hydrogen and oxygen fuel cell, right? So now let's look into the construction of this cell, right? Construction, like how this cell is constructed, how this cell is made, right? So basically, first of all, we have a electrode which has some pores in it, right? This is the electrode, and it has some pores in it, and basically it is a carbon electrode with a carbon coated with a platinum, right? This is carbon coated with platinum, right? Here basically platinum acts as a catalyst and plus the coating as well, right? We have another electrode which is also porous, right? There are some holes in it, right? And it is also made up of carbon with coated platinum. Carbon with coated platinum, right? And basically from here a hydrogen gas is released. From here hydrogen gas is released, and from here oxygen gas is released, right? And the electrolyte solution which we have is basically alkaline solution. The electrolyte is basically alkaline solution. Basically we have poured potassium hydroxide into this. We have poured potassium hydroxide to it, and let's join this with a wire. This is our bulb, and this is how we have joined it. Okay, so now we have two electrodes. Basically first is hydrogen, and second is oxygen. Basically the reduction potential of oxygen is more than the hydrogen. So basically the reduction potential of hydrogen is 0.00 volt, right? And oxygen, I don't remember, it is high. So basically, now according to this analysis, oxygen electrode will be considered as cathode, means reduction will occur, right? Reduction will occur in the oxygen on electrode, and hydrogen on electrode, like that will be known as anode, and their oxidation will take place. Right? Okay. Basically, okay, we know that when once kinetic energy is increased, like if for example there is an element and there is a gas, okay, and it's moving with high kinetic energy, so its reactivity decreases, right? For example, here we had hydrogen, right? And now its kinetic energy is very high, like it's very high, right? So its reactivity will obviously decrease. Its reactivity will obviously decrease, right? But like as I told you that these electrodes, so this carbon electrode is coated with platinum, right? So we know that platinum is a metal, right? Let me write it over here. We know that platinum is a metal, right? And basically it is an element. An element has atoms into this. It has atoms into this. Let's make the atoms of this platinum. These are basically atoms of, right? These are the atoms. So basically there is a space. There's a space, you can see over here, there's a space between the atoms, and in this space this hydrogen gas is trapped. This hydrogen gas is trapped in these spaces, in these gaps. So when it traps into these gaps or these spaces, its kinetic energy decreases. It becomes stable, and when its kinetic energy decreases, its reactivity increases, so it can easily react, right? So the kinetic energy basically over here decreases, and the reactivity of the hydrogen basically increases. Now what will happen is the reactivity increases, this hydrogen basically, we have hydrogen bond over here and hydrogen bond over here. So what will happen, it will lose its electron. So here 4 electrons will be lost, and here 4 hydrogen ions will be formed. Now what will happen, these 4 hydrogen ions will move in the electrolyte solution, right? 4 hydrogen. Now what will happen, this 4 hydrogen ions will react with these 4 OH ions, and they will form 4H2 molecules, right? They will form 4H2 molecules when these 4 OH and this OH will react together, and they will form 4H2O. Now let me erase these OH. Now basically what we have in the solution is we have 4H2 ions and these potassium ions, right? Now the electrons which were lost by this hydrogen will move in this wire, and they will come to the oxygen side. Over here oxygen is also very, like, it is not very reactive because its kinetic energy is increased. So what will happen, I just said there is a platinum coating over here, then like in the spaces between the platinum atoms, this oxygen gas will be trapped, and its kinetic energy will be decreased, and the reactivity will be increased. So as like by this process the reactivity of oxygen will be increased and the kinetic energy will be decreased, so it can easily react, right? So first of all, let's look at the reaction cathode, what actually happened over there. Sorry, anode. So at anode, what happened, there was a 2 hydrogen and it lost its electron, and OH plus 4 electron. Then this 4H combined with 4OH and they formed 4H2O. Let's look into overall reaction. This 4H, they got cancelled. So we have 2H2O plus 4HOH is equal to 4H2O plus 4 electrons. So this is a product by the anode reaction, right, where the oxidation takes place, right? Now let's look at the cathode's reaction. Now at cathode. Now basically we know that oxygen is present in this form. Okay, right. Okay, when it gets 4 electron, what will happen? It will break its bond and it will form like this. Like each oxygen, like oxygen has a valency of 2, so each oxygen will gain 2 electrons and it will basically form nascent oxygen. It will form nascent oxygen, right? Now this nascent oxygen will go in this solution, in this electrolyte solution, right? This 2 nascent oxygen will go in this electrolyte solution, and what will happen is this will react with these 2 water molecules. And what will form? This is plus, obviously here OH negative will be formed, and here OH negative and OH negative will be formed. So here now we have 4 OH ions. Now what's the condition of the electrolyte? We have, let me erase this now. Now we have basically 4 OH ions plus we have 2H2O. Now we have 2H2O. It means the solution, the electrolyte is now diluted. So when it is diluted, the specific gravity is decreased. Like the specific gravity of this potassium hydroxide is decreased, and because the specific gravity is decreased, its working capability is also decreased, right? So in order to increase the specific gravity, we will add concentrated potassium hydroxide into this. We will add concentrated potassium hydroxide into this electrolyte solution. So because as we will add this concentrated potassium hydroxide, its specific gravity will also increase, and it will increase its working capability, right? So I hope this fuel cell is clear to you. If you have any kind of queries, you can ask me in the comment section. I would be very glad to answer you guys.